Good morning, good afternoon. So it's a real pleasure to be here with you again today. One of the main reasons why I really love this conference is not just because it gives me the excuse to come to Australia, but because of something that Professor Dempster did at the end of the last conference 2 years ago. He did a good summary of what's taken place since the first Off-Earth Mining Conference, which was 4 years ago, and looked at what's changed. And I was really thinking about that when I made this presentation today. When I was first here 2 years ago, I was thinking, well, where are we going to be 2 years from now, which is today? And that's what you're going to see right now. So what I'll do is I'll introduce you to the company for those of you that don't know us. And then I'm going to talk about our phased approach to lunar exploration, which includes the Google Lunar XPRIZE, prospecting, and then the last stages of extraction, exploitation, and production storage. So we see ourselves as a junior mining exploration company. So for those of you in the room who are mining, you understand this completely. For those of you that don't know, the juniors are the ones that do the prospecting. And once we found something, we sell it to the seniors. And those are the ones that are coming in and going to do the big mining themselves. This was me 2 years ago. Not much has changed, a little bit less hair, more or less the same. A year ago, our company doubled in size, and this year, we doubled again. Right now, we have over 40 people, and we're hiring 20 more. So for those PhD students in the back, let's discuss this a little bit more. Right now, we have 3 offices around the world. We have an office at NASA AMES. We have an office in Luxembourg, and we have an office in Japan. And they're all doing different things. In Japan, we're focused on the Google Lunar XPRIZE. In Luxembourg, we're taking part in the Space Resource Initiative, which Mark will talk about later. And at NASA AMES, we're working on another project with Resource Prospector. And I'll talk about each of those separately. So this is our phased approach. And I don't put the years here because it's still a little bit hazy, but the one thing that we do know for sure is that the Google Lunar XPRIZE has to be finished by March 31st. Phase 2 is going to start just after that, from 2019 to 2025, and then moving forward from there, we're going to go into extraction, process, and delivery. So, for those of you who have been around, you know all about the Google Lunar XPRIZE. This is the international contest, the largest competition that's ever taken place, a $30 million competition to launch a spacecraft into space, land on the moon, and then you have to travel 500 meters either with a rover or with a lander. And you have to do that by March 31st, 2018. That deadline's been extended 5 or 6 times because when they originally made this contest, they didn't know how hard it was to actually do this. One of the key components of this is that it's all private capital. You can only get 10% government funding, so we have to raise money for this in other new and inventive ways. So we are one of the 5 remaining teams out of 30 that have went down this difficult path but somehow still managed to survive. And we've done so. We were able to survive because of our success in selling sponsorship. So some of these sponsors you're definitely aware of. IHI, some of you may know. Japan Airlines, most of you obviously know Suzuki. And what we do is we work with those sponsors, we put their logos onto our rover, and we provide them with marketing opportunities. So I want to show you a quick video of what some of these marketing opportunities look like.
世界中の空を飛び続けてきた JAL、その技術で彼らの夢と挑戦を応援しています。地球から38万キロ離れた月を目指し、世界屈指のロケット打ち上げ基地へ。お客様、年齢をお聞きいただけますか？
She's asking if he's comfortable.
ただいま JAL で移動中。
So that's just one small example. If you take a plane on JAL, that's one of the videos that you'll see before you sit down. And this gives these companies this opportunity to associate their brand with space. And everyone loves space. Space is cool. Space is super sexy these days. And definitely it allows them to associate their brand with high technology, which is why a lot of the companies are interested in doing this. So for us, The launch is just around the corner. We're going to be launching with Team Indus, which is another team in the Google Lunar XPRIZE. We're doing a ride share from Sri Hakuto. We're taking the PSLV, and I suppose most of you who are in the rocket industry know that the PSLV had a failure recently. That was very unfortunate, but the good news is that they're back on track and that they're going to be launching again soon. So we're still in a good position to launch. And we're going to the Mare Imbrium. So this is for you, Professor Dempster. I'm going to make a couple predictions in this presentation. And the first is my 2018 goal. There's the winner of the Google Lunar XPRIZE. Okay, so those are the 5 machines that are still in, and that's going to be the winner. So the next stage is prospecting. Now, I don't need to talk to many of this. I think most of you in the room are aware. Probably some of you worked on the instruments that provided this data. This is from Clementine, and it shows the iron on the moon. We can also see magnesium and titanium in the crust. The moon has a lot of aluminum, calcium, and of course silicon, which is extremely important when you think about the future considerations of in situ resource utilization. This is creep, so what we see here is thorium. And from a couple of studies, we realized that when you have high concentrations of thorium, you also find rare earth elements. And the most important one, hydrogen. So this is from LRO. Obviously the polar regions are one of those places that are the best, most expensive, high value property on the solar system because of the existence of water, water ice, and because of the existence of these permanent shadows which enable them, but also these permanent areas of light, which will potentially provide us with the solar energy we need to conduct mining exploration. So, as we all know, we want to use these for hydrogen, for fuel. We want to get industrial metals. We want to use breathable oxygen. Tons of things that we want to do with these resources. But how are we going to do it? There has to be a business case that's going to bring us from there to here where we are today. Now, what we are doing is hosting payloads on our rovers. This is the rover that you see we developed for the Google Lunar XPRIZE, and most of it inside is hollow, so there's lots of room for instrumentation. We are trying to make a rover that's agile, that's efficient, that's economical, that can be used for prospecting. So these are some of the other rovers that you've seen throughout history. Generally, they're pretty heavy. They travel different distances, but for us, we're really focused on this box right here. Now, these are a couple of the ongoing missions that we're doing right now. So at Tokyo, we're working with JAXA. JAXA is providing us with a dosimeter, which will help us to better understand the radiation on the lunar surface. We also signed an R&D MOU with JAXA to do lunar resource mining over the next 5 years. Tim asked what's going on in Luxembourg. I'm not going to steal the show from you, Mark, but we signed an MOU with the government of Luxembourg in March, and what we're working on is the roving spectrometer. Now, this is still in the proposal phase, but essentially we're hosting a mass spectrometer with a drill where we'll be sampling the water ice to better understand the distribution of water in the permanently shallow regions. These are the scientists that we're working with at the Luxembourg Institute of Science and Technology. And this is sort of the data that we want to bring back to better understand where we're going. And at NASA AMES, we're working with Resource Prospector. This is a near-infrared spectrometer. Again, this will help us to better understand the availability of hydrogen on the lunar surface. So, Professor Dempster, for 2020, I give you another goal. We will have not one, not two, but 3, there's the third one, 3 missions by the time I come back here in 2 more years. And this is the last and most difficult phase. I would also say the most murky. It's the production delivery phase. So we understand that a lot needs to happen. Right now, exploration is something that's on the minds of everybody, but when you get into extraction, production, and storage, transportation, there's a lot less that's known, and this is why. When you look, we did a little search at Google Scholar to understand what sort of papers are out there. And if you look at exploration, there's almost 20,000 papers on exploration. But then when you go into lunar utilization, extraction, reduction, production, it drops off. So again, those PhD students in the back, this is something that we really need help on. One of the biggest issues is that we don't really know what we're looking for. When you think about the permanently shadowed regions, there's areas on the moon that hasn't seen the sun for 4 billion years. We really don't understand what the mechanism of the sun are like. It's very difficult for us to develop a drill when we don't know what we're drilling into. And Bob, I hope you can help me with this later, because this is a very difficult problem for us. So this is my last prediction for the day. If you see what's going on right now, you can definitely see there's a return to the moon. In America, in Europe, in Asia, we're going back to the moon, that's for sure. Now what I'm going to say right now is that the early adapters, whether you're a mining company, a technology company, a communications company, or a PhD student, those that are jumping into this field right now, taking the lead, you're going to be a part of this $1 trillion cis-lunar economy that we're going to make. So if you think that your company is interested in partnering with us, if you yourself are interested in working with us, I just want to finish by saying that we are hiring. We have over 20 positions up on our website, and I welcome you to join us on this journey and help us, because it's extremely difficult, I can tell you that, and we need all the help we can get. So I have a couple more minutes left for questions. Thank you very much.
I didn't understand the ride share. How do you land?
So we're riding with Team Indus. Team Indus has their own lander, and we have a ride share agreement with them where they will deliver us. They also have their own rover, so this really brings more of a spectacle to the whole race, because they're going to land, their rover is going to come out, our rover is going to come out, we're going to line up and say 1, 2, 3, go. And as you can imagine, we don't have a satellite on our rover, so our communications is going through the lander. But as we are definitely going to be faster than them, they promised that they're not going to cut the communications feed just before we come to 500 meters. But for them, it's also a good opportunity because there's some redundancy built into their system. Even if we win, because we're getting the ride from them, we still have to do some prize sharing. So that's our plan for the 2018 Team Indus mission. Any other questions? Yes.
One of the toughest parts of the space mining business is protecting information. Obviously, various places you're going to explore, you're going to be visible. How do you protect your information well enough to build a junior business plan in mining when what you're selling is information?
Yeah, it's a very good question, Mike. So there's a couple things that go into that. First, as we know, there's no concept of property in outer space according to Article 2 of the Outer Space Treaty. So we still need to have some sort of protection over the areas that we go to. And for this, one of the things that we're looking at are safety zones. So we intend to work with the international community to create safety zones where wherever we are, there's no operations allowed within, I don't know, let's say 50 kilometers in the vicinity of where we are. So that helps us to protect our information on the moon. Now, whether or not the international community agrees with that, it's yet to be told, but I will tell you that when a lander lands on the lunar surface, there's dust that spreads out for a lot of kilometers, and that could really potentially impact our operations in a negative way. So having a safety zone is the first and most important thing. Secondly is when we get that data down to Earth and how we protect that data. And that's a cybersecurity issue. But one thing that the scientific community might be upset about or might not be used to is this data that we have, we don't intend to give it for free because we're not a space agency, we're a private company. And so we're going to be selling this data basically to the highest bidder. Now it's going to bring some new questions into the fold about how we do that. But again, I think it comes mostly down to cybersecurity and protecting that. Mr. Beasley.
for us, when we're looking at licenses for exploitation, we might be looking at maybe 100-year, 150-year concession. Because for us, like, depending on the orbit of the asteroid, our timing is kind of intriguing. How are you doing that from a lunar perspective? Do you want 1 year? Do you want 5? Do you want 50?
That's another discussion that I think we're having right now. You can imagine one thing we really want to avoid is these paper mines. So this sometimes exists on Earth where someone will say this area of the moon belongs to us. Actually right now, if you want to buy a couple acres on the moon, you can do that. You can pay $35 for an acre and some guy in Oklahoma is going to sell you some land. But what we want to avoid is these paper mine issues. So we envision having a sort of system where you have some land and that area needs to be used. There needs to be operations on that. As long as operations are taking place, that belongs to you. But these discussions are still taking place, and they still need to have a lot of international agreement on that thing. Yes.
Can you clarify this? Because what you just said involves property ownership. So if you say there is no property ownership, there's no property claim.
It's more of a safety zone, right?
Yeah. Right.
So again, we have this safety zone for as long as we're operating in that zone.
Okay.
Not necessarily a stake or a claim of that land because we can't do that.
Right.
But if we are operating in that zone, as long as we're operating in that zone, we'd ask others to keep out of that zone.
Right.
Any other questions? I have 20 seconds left. If not, come and talk to me after the break. Thank you very much.
Thank you.
What a fantastic speech. So we're going to hold you to those predictions, Carl, right? We're going to hold you. And we'll be cheering as we hear the news that breaks on the world stage. I'm now delighted to welcome Melissa Sampson from a company that both of our previous speakers have mentioned, United Launch Alliance, and really hoping to hear more about what you're doing in orbit and for the in-space economy. Welcome, Melissa.